Hello, data scientists. Welcome to Skillgate. While many argue that marketing is an art where marketers rely on their instincts, advances in data science have revolutionized this domain in a big way. Increasing number of marketers today rely on insights drawn from complex machine learning models to better their chances of converting leads to sales. In this course, we will cover one such analytics-enabled marketing project end to end. But before we go any further, let me quickly tell you a bit about us. We at Skillgate bring industry ready projects having real life complexity to you. Every Skillgate project solves a real business problem end to end through a data science approach. For every project, you would get a do it yourself kit having a dummy business case, problem dataset, and source code for you to solve these projects yourself. We launch new machine learning projects every 2 weeks, so make sure to subscribe to our channel to get access to all of our free courses. This also helps us in reaching out to more learners like you. Alright then, let's get started. This is Skillgate's problem solving framework. We will go step by step through this to understand, solutionize, and deliver on our project in hand. First thing first, let's understand marketing from a business standpoint and how analytics may help. Marketing refers to activities a business undertakes to promote sale of a product or service. When such activities are performed with some bit of strategic planning, it becomes a marketing campaign. Basic skeleton of all marketing campaigns is more or less the same. First stage is to make your target audience aware of your product or service offerings. Social media platforms like Facebook, Instagram, YouTube have made it immensely simple for businesses today to better reach out to their target audience and make them aware of the offerings through articles, posters, small videos, and podcasts. Second stage is where these people who are now aware of your offerings begin to consider you. Marketers call them leads at this point. These leads are curious to know more about your product or service and, if possible, want to try them out as well. This is the stage where marketers give free samples of their products or give massive first use discounts or send catalogs via emails. Third stage is where your leads are ready to make an informed decision. This is the part where sales team come in and engage with customers to give them product demos, answer their queries, show them customer testimonials, and take them through your product comparisons with your competitors. And in this fourth stage, magic in the name of sale happens. As you may observe, at every stage of this process, our target pool is shrinking, making it look like a funnel. This is what is called as a marketing funnel in business. Intuitively, to have more sales here at the bottom of the funnel, marketers need to make more and more people aware at the top of it. But sadly, cost is what that comes in their way. Let's understand this further. Marketers always work on a tight budget, and expectation from them is always to maximize revenue. In fact, companies decide on their marketing budgets as per this formula, which is gross revenue multiplied by a factor called marketing percentage. Marketing percentages are basically the portion of gross revenue at the end of a sales cycle that companies decide to invest back into marketing in the coming cycle. For example, a relatively new company allocates up to 20% of their gross revenue as marketing budget, while an established company doesn't go beyond 12%. Now, the point to observe here is if marketers somehow significantly increase gross revenue in a cycle, their marketing budget for the next cycle would automatically increase. But the question is, how? Well, this is where machine learning comes in. Given the limited marketing budget, marketers can only reach out to a portion of the total target audience. But what if they can segregate their entire target audience on the basis of their probability of buying? In that case, they may target the most probable buyers only and save the money they would have otherwise wasted on the ones with low probability of buying. This is precisely how analytics enablement can help any marketing function to maximize business revenue by smartly allocating their funds at scale. Alright, now when we understand the business use case for an analytics enabled marketing project, it's time for us to understand our dummy client ABC Supermarket's business case. Our client ABC Supermarket is a major retail player in the UK, running multiple stores. They run a huge loyalty program with 250,000 participants. Client has recently launched a new line of organic products and they wish to have a fast market penetration for these products, for which they are planning to run an analytics enabled marketing campaign targeting the loyalty base first. They have already given free sample kits to around 10% of their loyalty program participants and recorded their purchase decision. For the remaining 90%, they plan to run their marketing campaign only on the most probable buyers. They have shared data for the 10% having the individual's demographic plus loyalty program details along with their purchase decision. They have hired us to formulate an analytics enabled marketing strategy to target the most probable buyers from the remaining 90%, with the objective of optimizing profitability, keeping an eye on market penetration. Given revenue from a successful buyer is 15,000 Indian rupees and cost of promotional sample kit is 4,420. Let me take you through our dataset as well. These are the variables we have in our data file. The highlighted yellow ones are the demographic details on affluence grade, age, location, gender. And the red ones are loyalty program details on membership level, amount spent, and membership age, along with the purchase decision as 1 for buy and 0 for no buy. We have 22,000 observations, which is a fairly decent amount of data to use for model building. Here's the first few rows of our dataset for you to actually see what we have. As we may observe, here we have missing values we would need to impute during our model building. Also, we would need to convert these gender, location, and membership class categorical variables to numbers, as model building would take only numbers as input. We shall do all of it during the coding part of this project. Alright, now when we know about our job in hand, let's understand how we would go about solving our client's business case with a machine learning approach, with this next section on solutioning intuition. As our client is seeing their loyalty program participants as the marketing campaign target audience, let's quickly understand the importance of a loyalty program to any business. Loyalty programs are nothing less than a backbone to a retail business. Supermarkets need repeat customers to ensure steady sales, and loyalty program helps them achieve it. As per studies, loyalty program participants spend 5 times that of regular customers. They also do handy word of mouth marketing for the business. And because businesses maintain data for their loyal customers, they are a good candidate for an analytics enabled marketing campaign, and that's exactly what our client is trying to do as well. At a high level, our solution architecture is something like this. Using the dataset of sample loyal customers, we would build a logistic regression model, and then we would use this ML model to predict the probability of buying for the remaining loyal customers. Towards the end, we would use Decile Methodology to find out the right portion of these 90% loyal customers that our client shall target for optimizing their profitability, keeping an eye on market penetration. As we are using logistic regression for prediction, let's have a quick intuition on logistic regression. It's a classification algorithm that gives binary outputs like 0 and 1, true and false, yes and no, success and failure, etc. On a two-dimensional chart, this is how logistic regression curve is like for success and failure. Logistic regression models assign probability against each prediction, something like this. We are getting success probabilities as 90, 60, 40 and 20% here, which when plotted on a graph looks like this. As a data scientist, our part is to figure out a probability threshold for success, depending on clients' business requirements. All green crosses that are to the right of this threshold line would be success, and all to the left would be failure. So intuitively, with a conservative approach where we essentially minimize business risk, this threshold would move towards the right. That way, we are setting a high threshold for success. Similarly, with an aggressive approach, this probability threshold would move towards the left. That way, we are setting a low threshold for success. In our case, we would decide our probability threshold using Decile methodology, keeping in mind the business objective of profitability optimization with an eye on market penetration. With this understanding, we are all set to build our machine learning model. So, let's get coding. Before we get started on the model building part, there are certain prerequisites you would need to know. First, we would use Google Colab for Python coding, which is Google's free cloud-based platform. We have already done a small video on getting started with Colab. Refer to the description part below for the video link. Second, you would need to create a new folder with the name for analytics-enabled marketing in your Colab notebook folder, just like this, and copy all these model related files here. Link to our free Skillkit DIY toolkit having all these model files is provided in the description part of this video. Here, this 1.1 is our dataset for 10% loyalty program participants who received sample kits under the first phase of the campaign along with their purchase decision. This is the file we would use for model building. Next up, this 2.1 is our code file for building our ML model. Let's open it to get started. Alright, we are on Colab now. Let's go section by section through this Python code to understand what it does. First section is on importing data from Google Drive. For this, we first need to connect Colab to our Google Drive. To do this, simply run this first cell here and follow these simple steps. Alright, the drive is now mounted. In this next cell, we are setting the working directory to our newly created Google Drive folder. Next up, we are importing standard Python libraries and functions in this next cell that we would be calling later in the code. Let's run it. Let's import our dataset now. It's a success. For exploring our data file, we use these shape and head functions, where shape returns the count of rows and columns. Head function returns the first few rows of our data for us to see it. Here we have the results. Now we are into this next section on data preparation. Here first up, we are dropping the customer ID column as it would not go as an input variable for model building. Alright, it is done. Next up, we are using isNA function to check for missing values. As we can see, we have a lot of missing values here. Now we are imputing these missing values in this next cell. All categorical variables are imputed with mod and the continuous ones are imputed with mean value. Great, we have successfully imputed missing values. Next up, let's validate imputation once by running this isNA function again. We see all zeros, so we are good. Let's see how our dataset looks now with this head function again. As you may observe, we have many of these categorical variables here that have text labels. We need to do label encoding here to convert these text values to numbers, as our model would only take numeric labels as input. You may read more on label encoding by referring to the link attached in the description part of this video. Let's run this cell for label encoding. Alright, now let's have a look at our transformed data. As you may observe, we have only numbers now. Logistic regression modeling works on some assumptions, one of which is that input variables or features should have minimal correlation among them, a state which is called multicollinearity. To check for multicollinearity, we compute variance inflation factor or VIF values for all input variables and ensure those are under permissible limits. As a standard data science practice, VIF values under 10 put a good case for absence of multicollinearity. Let's check the VIF values that we have here. Well, as we may observe, all values are almost under the permissible limits of 10, so we are good. These permissible limits, however, vary from industry to industry, so please give that a check when you are checking for multicollinearity. Next up, we are defining our variables x and y. And then we are using the train test split function for splitting our dataset into training and test in 80-20 ratio. Alright, now we are all set to build our logistic regression model. Let's do it. Great, our machine learning model is now ready. In this next cell, we are storing our model coefficients file back to Google Drive to use it later for predicting buying probabilities for the 90% loyalty program participants dataset. Next up, we are checking model performance by plotting this confusion matrix. With this next cell, we are computing our model's accuracy score. As you may see, it's a healthy 80%. So we have indeed done a great job. Congratulations to you for that. Next up, we are computing the probabilities of buying and not buying for our test set. With this last cell, we are storing this model output file having test set observations along with model predicted probabilities back to Google Drive. And indeed, coding ends here from model building standpoint. As you may observe now, our classifier file and model output file have gotten created here on our Google Drive project folder. Now let's analyze our model output file further using Decile methodology to formulate a data-driven marketing strategy for our remaining 90% loyalty program participants. This is our model output data where we have our test set observations mapped with actual purchase decision to model predicted probability on purchase decision. Next up, let's apply Decile methodology on this dataset to segregate it into 10 equal parts in decreasing likelihood of buying. For this, we first need to sort this data in descending order of probability of buying. Alright, now intuitively speaking, we have most probable buyers on top of this list and most probable known buyers towards the end of this list. Let's introduce deciles now. As we have 4,445 observations, we would have decile sets of 445 each. So let's add a new column and call it decile. Now let's put 1 against the first 445 observations. For remaining, use this simple formula to get the job done. I have already done this entire calculation in this sheet number 2. As you may observe, for each decile we would have a maximum probability and a minimum probability, which is this 54.84% for decile 1. Now we would insert a pivot on these last 4 columns. I've already done it in this next sheet. Here we have our 10 deciles row wise. We have count of observations against each decile. Then we have minimum of probability of buying for each decile in this third column. Then we have count of actual outcomes equal to 1 for each decile. So intuitively, these many loyalty program participants from decile 1 actually decided to purchase. This next column is the percentage good in each decile. As we go down from decile 1 to 10, we see percentage good as dropping continuously, which is expected. Next up, we have the count of customers who did not buy, which is basically total minus good. Then we have cumulative good, which is essentially cumulation of this column good. Similar way, we have cumulative bad, then percentages of cumulative good and cumulative bad. And at last, we have percentage cumulative bad avoided for each decile, which is 100% minus percentage cumulative bad. Now we are all set to formulate a data-driven marketing campaign strategy for our remaining 90% loyal program participants base. As we already know, revenue from a successful buyer is Indian rupees 15,000 and cost of promotional spend is rupees 4,420. Using these two numbers, we can compute profit for each decile. Here we are multiplying cumulative good with the revenue from successful buyer and subtracting marketing cost, which is sum of cumulative good and cumulative bad multiplied by the promotional sample kit cost. The final number is the profit at each decile. As we may observe, profit maximization occurs at decile 2 and 3 with slight variation. So for profit maximization, business should definitely run their marketing campaign only on the top 30% of the remaining 90% participants basis their probability of success. However, as we are also told to keep an eye on market penetration, even this decile 4 seems favorable with slight compromise on profitability. So from a market penetration standpoint, business may also decide on running campaign for the top 40%. With this, we have successfully formulated a data-driven marketing strategy for our client ABC Supermarket. One important thing you might be thinking at this point as to how would we generate probabilities for our 90% dataset. For this, we have already built this predictor file that would return buying probabilities for input dataset. Let me quickly take you through this as well. Over here, first we mount our Google Drive. Then we are setting our working directory to our Drive folder. Next up, we are importing standard Python libraries and functions. In this next cell, we are importing our 90% dataset. This is how our dataset looks, which is exact same as the 10%, except that we do not have purchase decision here, which is understandable. In this next section on data preparation, we are first dropping customer ID. Alright. Then we are imputing missing values the exact same way we did in the model building part. Let me quickly run it. Then we are converting categorical variables to numeric. As you may see, we have all numbers now. For predictions, first up, we are defining our x. And then we are calling our classifier coefficients file that we exported to Google Drive in the model building part. Alright, in this next cell, we are generating predictions on the 90% dataset using our classifier file. With this predict proba function, we are computing model predicted probabilities for buying, not buying. And then we store this output file back to Google Drive with this last cell. Great, our output file should be stored back on Google Drive. This 4.2 here is our output file for 90% along with model predicted buying probabilities. Let me open it. Basis this strategy, our client finalizes on either picking top 30% probable buyers or picking top 40% probable buyers if market penetration is to be looked at with slight compromise on profit. This 90% prediction file would be the one they would use to demarcate target customers and plan out their marketing campaign. With this, we're almost done with our analytics-enabled marketing project, except for the last part where we make a delivery presentation back to our client ABC Supermarket. For this, we need to prepare a client solution delivery presentation, something like this. Let me quickly take you through this as well. Our deliverable for this assignment was the formulation of an analytics-enabled marketing strategy to identify and target most probable buyers for the new marketing campaign on organic products. These were our assumptions. We imputed missing values with mode for categorical and mean value for continuous variables. And we used label encoding for converting text labels to numbers. Then we trained our machine learning model to predict buying probabilities for 90% dataset using logistic regression. As a deliverable, we have built our machine learning model with 81% accuracy. As we have used Google's free computational resources, there is minimal operational cost to business with our approach. These are the three strategic options our client may choose from for the upcoming marketing campaign. As we may observe, in a no model scenario where our client runs a marketing campaign on the entire customer base, they are losing 176 million rupees. On the contrary, if they do go with our strategic option of running a focused campaign on the top 40% of most probable buyers, they gain 196 million rupees. And in fact, if they only look at profitability without eyeing market penetration, they can sure maximize their profit at 214 million rupees. Alright, with this we have completed our course on analytics-enabled marketing. Please share your queries and feedback in the comment section below. And if you want to see more such machine learning videos, do like, share and subscribe to our channel. See you next time. Till then, keep learning.